Okay, question 3. Triangle ABC is shown below. Calculate the length of AB. I should have really said this at the beginning actually. I sometimes forget. Feel free just to turn these videos on, pause them, do the question yourself, and then just skip to the end to see if your answer looks similar. Do you know what I mean? Totally fine doing that. I try and throw loads of random information as we go through it, but if you're quite confident or you're just looking for seeing some of the working laid out, that's fine as well. So if you hear me take a wee pause, that's me giving you a chance just to pause the video. I've not passed out or anything. Okay. So triangle shown below, calculate the length AB. So I'm just going to mark that up as cot X. Right. Now, part of doing these papers is your higher order thinking skills. Okay, it's trying to apply what you've learned. And in a classroom, if you're going over a topic, it's easy to just apply that topic. You know that's the topic, and your brain just accesses that little bit of your memory, and just keep doing it and doing it. But in the papers and the exams, it's hard because you've got all these different questions that are drawn all the different information that maybe you've tucked away somewhere, or it needs something to bring it out. Okay, and you might look at this and go, how do I do that? So whenever you see angles and lengths and triangles, you should always be thinking sine and cosine rule. Okay, maybe SOHCAHTOA, maybe Pythagoras, possibly, but definitely sine or cosine. Now, the cosine rule uses 3 lengths. So if we get 3 lengths, so there's an unknown, there's 2 known, we should definitely be thinking this is a cosine question. Okay, the sine rule, that's our 2 lengths and 2 angles. Okay, so I always think if there's 3 lengths, definitely cosine. If it's not cosine, it's probably going to be sine. Okay, so there's our equations up here. They even give you the 2 versions of it as well. So you don't even have to rearrange the equation. So we're going to use this one here. Okay, so a squared is equal to b squared plus c squared minus 2bc cos a. Okay, so a squared is equal to b squared plus c squared minus 2bc cos a. Right? Now, this is quite interesting because we've got the a, b's, and c's here, right? Which is fine. But the point when you're doing these triangles of the a, b's, and c's, I would be thinking, in fact, you know what, I'll label up on, yeah, you know what, I'll label up on this one. Okay, so if they've called these angles ABC, which is the proper way, this length would actually be length A, okay, this length would be length B, and this would actually be length C. Okay, I've called it X, but it would be C. And the point is that the same letters are opposite each other. Okay, so we've got capital A is the angle, length A is small. Okay, when we're using the cosine rule, B and C can be anything. Doesn't really matter if you mix B and C up. Okay, so but the thing that you need to make sure you get right is the A's. Okay, so you need to look at the angle opposite the length you're trying to find in this equation. 1.2 and 1.35, I can call either of them B or C. It doesn't matter which they go into. Okay, it'll just come out in the wash. But it's imperative that this A and this A are these two. Okay, so it's the angle opposite the length I'm looking at. Now in this case, there's only so many variables, so actually you shouldn't be making a mistake. But imagine they gave you this. Imagine they said, "Oh, this is 80 degrees." You would have to know which angle to use. Okay, so when you're doing these, please remember that it's the A and the A are opposite each other, the B and the B are opposite each other, etc. Okay, so when we're trying to find this length, that's the angle I'm using, and they're the A's. Okay, the B and C can be either. There's not really, you don't have to. That can be B, that can be B, that can be C, that can be C. Okay, so that's the first thing. So we've got our equation, spotting that because there's 3 lengths. We know it's cosine, and then knowing that this is the angle and this is the length that are going to occupy the A spot. Okay, so let's just write that out. So we get A squared is equal to, I'm going to say 1.2 squared plus 1.35 squared minus 2 times 1.2 times 1.35 times cos of, oops, that's funny, I've done that a few times before. Cos of 35. Now sometimes the question actually, instead of giving you the angle, states what cos of 35, it might just say cos of 40 is equal to a third, in which case this term would actually be 1/3. That's more common in the non-calculator paper. Okay, but just be aware that's how they can also dress the question up. So again, people get confused by that. It says cos of theta is equal to an eighth. Okay, but yeah, so they wouldn't give you the degrees. You just say cos of theta is an eighth, and then people in here put cos of an eighth, but it's not. This whole term would be 1/8. Okay, so just remember that as well. Okay, calculator time. Let's see. So I've got 1.2 squared plus 1.35 squared, and I'm just going to put that in a bracket. Okay, just so my calculator doesn't do anything silly. So that term is in a bracket. So in my calculator, it actually looks like this. Okay, that's my positive bit. And then I'm going to put this bit here in a bracket as well. Okay, that's just the way I like to lay it out. The point is, I just like to know there's a wee bit of redundancy on there, and I don't like the idea that it might do -2 and then times the whole lot by this amount. Okay, so I just for belt and braces, I feel more comfortable knowing that those brackets are in there. Okay, and it's cos of 35. Okay, so that is giving me 0.608. Okay, and what a lot of people then do is say, okay, what's my units? Kilometers. Finished. Okay, no. Okay, now if you look at that, that's actually not a ridiculous looking answer, and that's the problem with this question. Sometimes this answer is ridiculous. Okay, but that's actually not terrible. I think you could argue it's maybe a wee bit going to look a bit bigger than that, but actually that's a ballpark, probably correct kind of number. Okay, that's a problem. But what everyone forgets to do is square root it at the end. You've got a squared, so you need to do a is therefore equal to the square root of 0.608. So if we do the square root of that, square root of 0.608, that's going to give me 0. I'll just call it 78. Just round it. Okay, I'm just going to check the question doesn't have any rounding issue yet. Sometimes it says to the nearest, whatever. So that's how I would do that question. All right. I like the brackets in my calculator. I'll probably over bracket, but I think it's quite good to do that. Don't forget the a squared. That's a classic mistake. Okay. So your 3 marks for this one. You're getting a mark for your first line of your substitution. You're getting a mark for getting to here, and then a mark for your final answer. So you actually get a whole mark just for um, square rooting that number, which is pretty generous considering you only got a mark for doing all that. So yeah, I don't think they're difficult. I think when you see triangles and angles, think sine and cosine, 3 lengths, that's your cosine. All right, so far nothing difficult. That's 10% in the bag. Another 3 marks in the bag as well. Okay, so we're close to getting up to 20% of the paper correct. Okay, without much thinking. Right. Vectors. Find the magnitude of vector u. Now there's a few rules with vectors. So say I've got a vector. Let's just do the kind of x and y vector. So vectors are, I'll say x, y, and z. Okay, so this is what the vector effectively means, isn't it? You've got your x-axis, you've got your y-axis, and you've got your z-axis. Okay, and it's basically how many are we going along x, y, and z. Yeah. So we've got this kind of arrow in 3-dimensional space, and it's, well, how much has it travelled in the x, in the y, and then in the z. Okay, and that's our vector. All right, so that's what we've got. What if we want to add them together? If I've got a vector here, say that's u vector v. Okay, if I add them together, I get vector u plus v. Okay, now you can add them. To add vectors, they've got to be head to tail. Okay, and if you add them in component form, so say that's, that one looks like it's going along 2 and up 2 for this one, and then this one's going along 2 and down 2. Okay, add them together, that gives me 4, 0. I'm just adding the tops, and I'm adding the bottoms. And it makes sense, that one, doesn't it? I'm going along 4, not going up any. Okay, so if you're adding them, you're doing that. If you're multiplying them, so say I want to get 2u, so say there's my u, 2u is just, u and u, yeah? So if u is going along 2 and up 2, then 2u is going along 4 and up 4. Okay, so u, 2 and 2, 2u would be 4 and 4. You just multiply this number and this number. Okay, so the vector is twice as big. It was going along 2 and up 2, now it's going along 4 and up 4. Simple. Okay, so yeah, I think there's a lot to vectors. Usually they give you a diagram, which can make it a wee bit more interesting, making you think about it. But yeah, that's a little bit about adding and multiplying vectors. Magnitude, I think, is very straightforward. I always think of Pythagoras. Okay, so like we said, you've got, let's just think of a 2, an x and y vector. You're going along and you're going up. So if I'm going along, let's say 3, and I'm going up 4. Okay, I'm going along 3 and up 4. Okay, so there's my vector there, vector u. Okay, and I would write that in component form as 3, 4. Oops, I thought you would lose a mark for that actually, but that's bad form, not a fraction. Okay, so there's your vector in component form, 3, 4. What's the magnitude of that vector? Okay, so if we said that's u, what's the magnitude of u? Well, I think of the magnitude there as like, it's like Pythagoras, isn't it? If you've got a right angle triangle here, if someone said work out the length of this, you'd say, okay, well, that's Pythagoras add, that's 3 squared plus 4 squared, square root. Yeah, and it's really just the same for the vectors. Okay, you're kind of working out that hypotenuse, if you want to think on it that way. Okay, this is given all the different components, how far along into the page, up the page it's gone, but what's the kind of final resultant? Okay, so you're quite simply just going to do 6 squared plus minus 13 squared plus 18 squared, and then square root it. Okay, so it's the same. You've got the z term, which obviously we don't have in Pythagoras, but it's just the exact same thing we're doing. Okay, so if we get that into our calculator, we should end up with 23. Okay, watch out for your negative there. Okay, so that'll be a positive number. Okay, but yeah, it should be nice and straightforward. Well, 6 squared is obviously 36. Is 13 squared 169? Is that right? Yep, and 18 squared, I always forget. 324. Okay, and then square root them. Obviously, you'll have a wrong answer if you don't square root it. You'll have a massive number that won't quite look right. Okay, so yeah, magnitude is very straightforward. Again, that's 2 easy marks. That's us now. I would say that's 20% of the paper, or 1/5 of the paper, right? And I would not say you've had to think that hard. Okay, this is very straightforward. It comes up all the time as well. It should be right at the front of your mind. Okay, we're just substituting for an equation. Just substituting in. They've not even given us other things to trip us up. They've not made us work for this angle. Just substituting into an equation. This, fantastic. 3x plus 2 is equal to 23. That's first year work. And with the percentages, I think that does seem to confuse people, to be fair. But really, when you think about it, you're getting 3 marks for writing down 3 numbers. The value, a decimal, then known to put a square there. I mean, I think for 20% of the paper, you should be sat down right now thinking, okay, I've got some good points in the bag. I can definitely get a pass. Definitely. If you're strict, that's what you're aiming for. You should be thinking, I can definitely get this pass. Okay. But yeah, not a lot in there. I'll do that in the next video.